So we're going to go over question 2. Welcome to my YouTube channel. I'm the Universal Data Boy, or you might as well call me the E+ Ambassador. So now in this video, we're going to be revealing the solutions for EGM 211. So the question was the integral of to the limits pi over 4 and 0 of 8 cosine 2t over the square root of 9 minus 5 sine 2t dt. So now there are many ways that we can use to evaluate this integral, but the best would be to use the u substitution, because when you substitute 9 minus 5 to be u, we're going to get the derivative to be cosine 2t, of course with some other coefficient, but then the cosine 2t and the other one will cancel. But then when you try to use any other, it's going to refuse in this case. And then for integrals, there is actually nothing like a quotient rule that can magically work here. So now we let 9 minus 5 sine 2t to be equal to u. So then our du with respect to t, when you differentiate t with respect to t, we have 9 is just a constant, so it's 0. Then this negative 5 is also a constant, so we put it outside. Then the derivative of sine 2t is 2 cosine 2t. So then you can say du over dt is equal to negative 10 cosine 2t. So then you can make du subject to the dt subject to the formula by cross multiplication. So du is equal to negative 10 cosine 2t dt, and then when you divide both sides by negative 10 cosine 2t negative 10 cosine 2t, we have dt to be equal to du over negative 10 cosine 2t. So now wherever there is dt, we are able to replace it with this, and then wherever there is this, we can replace it with u. So now let's do the replacing. The integral to the limits pi over 4 of 8 cosine 2t over the square root. Where there is this, we're going to put u dot, where there is dt, we're going to put du, because we found it. And then the main essence of putting du here is so that we can change the variable of integration from dt to du, because the t's will cancel out, then we remain with u. So now here we have the negative 10 cosine 2t. The cosine 2t can cancel out with that one, and then we'll have the integral pi over 4 0 of 8, this one is negative 10 square root of u du. So this can be pushed outside. When this is pushed outside, we're going to have 8 over 10 as a negative pi over 4 0 of 1 over the square root of u du. So now we can find this one by changing all of this into a power, and then since it's to du, it's very easy. So let me just flip a page. Yeah, so we are having negative 8 over 10 this integral to the limits pi over 4 of 1 over the square root of u du. Yeah, so now the question here, we can simplify this one. It will be negative 4, then down there it will be 5 when we factor out 2, and then we'll make this one to be a power. We'll make the radical into a power as u to the power negative 1 over 2 du. So now this one, we're going to just use the power rule of integration. So we've got pi over 4 0, and then this u to the power negative, let me just write it down again. So now using the power rule, we are going to have u to the power negative 1 over 2 plus 1 over negative 1 over 2 plus 1 to the limits pi over 4 and 0. Never forget the limits of integration. And then if there are not the limits, we could just add a plus c. So now we have got 4 over 5, and then we know negative half plus 1, that's just half. 1 over 2, 1 over 2, pi over 4 and 0. So now this half these 2 can go to the denominator. We are going to have 4 over 5 2. This u will become the square root of u, because we'll change now the power into a radical so that we can evaluate once we plug in the limits. So at this point we can just try to plug in the limits, but then remember these limits are with respect to t and not u, so we have to change u into t so that we can now replace these variables. Or you can try to apply the change of variables, where you try to put these in the equation that has u and the equation that has t, then you replace these limits of t to find out what happens to u when t is pi over 4 and what happens to u when t is 0. So now we're going to now change u with t, since we know u is now a function of t. Remember in our last on the other paper we let u equal to 9 minus 5 sine t, so we're going to replace this one there, 9 minus 5 sine 2t, and then never forgetting our limits of integration. So then we're going to have this one as negative 4 over 5 to 5 minus 9 minus 5 sine 2. Our t is pi over 4 minus 2. Then in the other one our t will be 5 minus sine 2 times 0, which is just a 0. So negative 4 over 5 to here we are going to have the square root of 9 minus these 2 and then these 4. They are going to cancel out, so we're going to have pi over 2. Pi over 2 is 90, and 90 times sine 90 is just 1, so we're going to have this one as just 5. Then 2 sine 0 is just 0, so we're going to have 9 minus 0, which is just as good as saying 9. So 4 over 5 the box brackets 2. This one will be simply 4, because 9 minus 5 is 4, and then the square root of 4 is 2. Then 2 minus the square root of 9 is 3. Negative 4 over 5. Here we are going to have a 4. Here we are going to have a 6. So 4 minus 6 is negative 2. So I have the negative 2 there. Then negative 2 times negative 4 is 8 over 5. Then thus you can conclude, you can say therefore the integral with the limits pi over 4 and 0 of 8 cosine 2t over 9 minus 5 sine 2t dt is equal to 8 over 5. Thus you have evaluated your integral.